Okay, let me start my presentation. Okay, thank you very much for having me a chance to presentation in front of you. My name is Ryoo. I'm working for Samsung Electronics as a principal engineer. So the title of today's talk is Meeting Petabyte-scale memory systems challenges with a CXL memory pooling. So today I will talk about the memories industry's trends and challenges of modern memory system and computer architecture system. And I will also introduce Samsung CXL-based memory expanders. And at the end of the presentation, I will invite our co-workers. We will show our collaboration model with Xconn. So Gerry, CEO of Xconn, will present our collaboration model at the end of the presentation. Okay, let me start. So everybody in this room talking about the memory-centric and data-centric. So memory-centric is the biggest feature of future computer architectures. Everybody knows. And total amount of data processing is drastically increased. And Samsung, as a memory company, we really want to grab this kind of chance. But despite of this kind of opportunity, advantages, we still have crucial issues. Everybody knows that it's not easy to satisfy future computer architectures, memory systems, even data centers by using current memory system. So everybody think about some other solutions. But in this slide, as you can see, AI, machine learning, and data center-based new kinds of application is coming out. So it is some kind of headache. So we have to resolve this kind of huge data management issues. So that's the reason why we also focus on this kind of new interconnect protocol. So when you think about the some relationships between CPU core count and the memory channel bandwidth per core. So this slide shows the relations between computing and the memory channel bandwidth per core. This slide, as you can see, there are some gap between CPU core count and the memory channel bandwidth since 2012. When you recall the 2007, memory bandwidth per core about the maybe 6.5 gigabyte per sec. But in 2019 and 2020, this kind of memory bandwidth per core is about 3.5 gigabyte per sec. So reducing this kind of gap is very, very important to design future memory system. But we also have a solution. So we can easily add, not easily, we can add our memory channel and we can increase the data rate. But this is closely related to the TCO. So that is not the final solution. So this is one of the important and very severe headache. So our great smart guys, our data center guys, trying to invent some very fascinating system. In this slide, as you can see, well, hyperscale computing environment is evolving from converged to composable infrastructures. In this slide, as you can see, so converged architecture is based on the TOR based architectures. In this slide, as you can see, when you design this kind of memory data centers, some network is one of the big issues. So Microsoft Catapult and the Amazon's Nitro is one of the examples to mitigate this kind of issues. So they invented SmartNIC. But when you think about the hyper-converged architectures, which is a server and storage combined architectures, we also have to think about the divergence. Even this architecture is very fancy, but we also have to think about some divergence. That's the reason why these days we are focusing on the disaggregated composable architectures. So this is very fancy. This is based on the full architectures. Memory, compute, storage is isolated. For that, memory interconnect is, this kind of inlet interconnect is much more important. That's the reason why we are much more focusing on the CXL protocol. Okay, so everybody in this room always understand the CXL 2.0 and CXL 3.0. So we already mentioned about, I briefly introduced about the CXL 2.0 and 3.0. So CXL 2.0 is very, very meaningful event for the CXL consortium. So by using a CXL 2.0, we can easily support memory switching and pooling. So switching enables the memory expansion, and pooling increases the system efficiency and utilization by allowing the allocation and allocation of the data. So, and persistency is also possible, and integrity and some security is also possible by using CXL 2.0. And by using CXL 3.0, double the bandwidth without any latency delays is possible. In this slide, as you can see, coherent memory sharing and multi-level switching and massive scalability and CXL fabric is possible. So we really welcome the CXL society. So this is very, very good progress. They published the CXL 3.0 in the August this year. So Samsung also want to contribute this kind of build a CXL ecosystem. So we introduced our FPGA-based CXL memory expander in May 2021. So we have been validating and testing with our customers. So I cautious to say that this is one of the driving force and catalyst of CXL, making the CXL ecosystem. And today and now, I'm very proudly introduce Samsung's world first and high density CXL ASIC-based solution. So we announced our ASIC-based CXL memory expander in August this year. So let's take a look at step by step. So its specification is follows CXL 2.0, and this form factor is based on the EDSS form factor, especially E3.S2T. And media is currently media is based on the DDR5, but we also can use the DDR4 for the low-cost solution. So you can choose it. And the CXL link with like this, and we can also follow the maximum CXL bandwidth. And most important thing, the most big difference is between current DRAM and the CXL DRAM is that we can wisely, easily, smartly use our controllers. So we are trying our best to collaborate with our third-party controllers. So some other features included. So if you are interested to receive our Samsung's CXL memory expander, please feel free to contact me. And finally, I will also introduce Samsung software contribution. So this is we call this SMDK, Scalable Memory Development Kit. This is kind of software toolkit. You can freely download it in the GitHub. And by using this software toolkit, you can more easily use Samsung's CXL-based memory expander. So by using this, we can optimization and comparable. We have two APIs, comparable APIs and the optimization API. You can easily choose it. And we also have intelligent tiering engines on memory management. So by using this, you can allocate your tiering memory or something like that. So the thing that I really emphasize at this point is that Samsung really welcome the collaboration with our industries. So I think this is one of the important events for the Samsung's collaboration willingness. So I will take it over to the Gerry. So Gerry will explain about Samsung and Xconn's collaboration model.
Thanks, Casey.
Mm-hmm.
All right, I'll take it over here. Okay. Yeah, I appreciate that you asked us to join this presentation. How do I? Okay. So before I start, let me just give a very quick introduction about myself. My name is Gerry Fan, and I'm one of the co-founder and the CEO for Xconn. So Xconn is about 2.5 years, and we are a very young startup and well-funded as well. So we made a lot of progress in the CXL switch area, and we appreciate the opportunity at early stage can work with Samsung to address these very exciting things in memory pooling. So, the the Xconn, we tape out our first the high-performance CXL switch in the February of this year, and we get our chip silicon back in the middle of the summer. And the chip we are having right now, which is collaborating with Samsung and other vendor, the partners is, so we supporting the first CXL 2.0 switch fabric, and we have the largest capacity in the industry. And so totally we have 2 terabytes bi-directional the bandwidth for our chip, and our chip also have the largest integrated SerDes. And because our chip is optimized for the CXL switching, so we can have very much the lowest port-to-port latency, and also the very low power consumption, and because it's very critical for the data center applications. So right now, our chip is under the validation, and for our first engineering sample for customer to sample will be starting next January. So, this is much easier here. So, I just want to highlight a few of the main features about our chip. And our chip primarily is for the CXL switching, and all the design and the architecture is optimized for the short latency and high throughput. So, and of course, we fully comply with the CXL 2.0, and on the 5 layer with PCIe Gen 5, and of course, and we support the CXL.io and .mem and .cache, and and also our software team and have this fabric manager, and for CXL 1.1 and CXL 2.0. And some folks might say that CXL 1.1 is only point-to-point, and it's not going to have the switching capability. So that's exactly the right question to ask. And because our chip has virtualization to make this CXL 1.1 to be able to routing in the CXL 2.0 fabric environment, because of the existing or the forthcoming the major CPU is still going to be 1.1. So that's our chip exactly is also designed to address these type of needs. And for 2.0, we support the multiple logical device, and so that can enable memory pooling. And for 2.0, obviously, there's a multiple, virtual, they call the virtual CXL switch, and basically is to enable the multiple hosts, especially for the CXL 2.0 host, to be able to do the memory pooling. And and our device is also, we can support the type 2 and the type 3 memory device, because some of the CPU support the memory type 2, and some of the CPU support memory 3. So, and we have this ability to support both. And in order to have a bigger capacity of the memory, and we can support up to the 32 ports, and for each port is going to be by 8, and with a bifurcation. And we have the full RAS support, including all the ECC, DPC, hot plug, these type of capabilities for CXL 2.0. So the following, I just want to touch about the main applications. So one of the simple and the most straightforward applications is for like memory expansion. So that is mainly for CXL 2.0 hosts. They can talk to our switch, and we very much function like a fan-out switch, and with each the downstream ports able to connecting with the CXL device. And since we have like 32 ports, and ideally, in theory, we can go up to 31 terabytes, which is a huge amount of memory space for a lot of these in-memory computing, these type of applications. So for the multi-host, the memory pooling and the memory sharing side, and as I mentioned earlier, our chip, we can connecting both CXL 1.1 hosts or CXL 2.0 hosts. So we have this switch fabric manager software, basically is provisioning our chip and also chassis, and to do this memory a dynamic allocation and a deallocation to enable memory pool and sharing. And for memory sharing, and since this is a 2.0, and so we adding these things unconventionally into this feature, per our customers' request, that's also enable some of them advanced applications, which is officially is going to be available for CXL 3.0 spec, but we have that feature to be enabled for any of our customers which is interested to the memory sharing. So this is my presentation, and we have, as I mentioned, that we are a young startup, and we like to be the great players in these ecosystems. And as people said that this is a collaboration effort between the companies across the board, from the system, from the cloud providers, from the switch vendor, from the device vendor, and also software vendors as well. Okay.
Thank you very much.